Hello students, welcome to the class. So in the previous class we had started with the multiple choice questions on the topic of classification of elements and the periodicity in the properties. Around 19 questions we had solved. Moving to the next question, among the elements calcium, magnesium, phosphorus and chlorine, the order of increasing atomic radii. So they have given two elements calcium and magnesium which belong to group 2, phosphorus and chlorine belong under P block. So these two come under S block. So we are going to discuss across the period. Okay. So these all belong to which period? Beryllium belongs to second period. Magnesium belongs to third period. So all these elements belong to third period, right? Now see the atomic radii. When we speak about the atomic radii, they have asked us atomic radii. The atomic radii, it decreases across the period. Across the period. That is, when we are moving from left to right in the periodic table, the atomic radii goes on decreasing. Yes, thus the order of sizes, if you consider, they have given calcium, they have given magnesium, they have given phosphorus, they have given chlorine. Thus the order of sizes for chlorine, phosphorus and magnesium, if you consider, yes, these are in the order, right? Calcium comes somewhere below. So if you consider this, which is having smaller size, least size is for chlorine. So chlorine has got smaller atomic radii, smallest in these among these elements. Then comes what? Then comes phosphorus and then comes magnesium. Okay. And down the group, what happens? The atomic size increases. So below magnesium is calcium. So as you move down the group, atomic size increases. Therefore, magnesium less than magnesium, atomic size is what? Calcium. So what is the correct order? Chlorine has the least atomic size. Then comes phosphorus. Then comes magnesium. Then comes calcium. Then comes calcium. So correct option is option chlorine less than phosphorus less than magnesium. So it is option B. It is option B. Among the following, which one has highest cation to anion size ratio? Cation to anion size ratio. Cesium iodide, cesium fluoride, lithium fluoride and sodium fluoride. So they have asked, this is some question which we have not come across anytime, right? So they have asked us cation to anion size ratio. Size ratio. Yes. The cation to anion size ratio, it will be maximum. It will be maximum when cation, I'll write it here, when cation is of largest size and anion is of smallest size. Cation is of largest size, anion is of smallest size. Yes, because you know cation to anion ratio. So numerator should be largest, denominator should be smallest, then cation to anion ratio will be maximum. It will be maximum, right? So cation is in the numerator, anion is in the denominator. So cation should be of largest size and anion should be of smallest size. They have given us options cesium iodide, cesium fluoride, lithium fluoride and sodium fluoride. Let us first identify which are the cations and which are the anions. In this case, cesium is cation, iodide is anion. Cesium is cation, fluoride is anion. Lithium is cation, fluoride is anion. Sodium is cation, fluoride is anion. So anions are fluoride and chloride. Cations are lithium, sodium, and then cesium. So we know that as you move down the group, lithium, sodium, potassium, rubidium, cesium, francium, all these elements come in a group. As you move down the group, atomic size increases. So which is having largest atomic size? Cesium is having largest atomic size. So cesium has maximum ionic size because it is an ion. So I will say ionic size. And the anion should have smallest. So as you move down the group, the size of anion becomes what? It increases. Therefore, this is having fluoride. Fluoride ion has smallest ionic size. ionic size. So when cesium ion combines with fluoride ion, it will have cation to anion ratio the highest. So I can say thus for cesium fluoride, the cation to anion ratio is highest. The ratio of cation to anion is highest. That is highest. Yes, understood. So the condition is the cation, it will be maximum. Cation to anion ratio will be maximum when cation is of largest size and anion is of smallest size, and it is for cesium fluoride. Cesium fluoride. Next, amongst the elements with following electronic configurations, which one of them may have the highest ionization energy? So now if you see here, in this case, it is neon 3s2 3p2, argon 3d10 4s2 4p3, neon 3s2 3p1, and neon 3s2 3p3. Neon means atomic number is 10. So here it is 14. Argon is atomic number 18. 18, 28, 33. This is 10, 13. This is 10, 10 and 15. So these are the elements. Yes. In which one of them may have highest ionization energy? Okay, highest they have asked. If you carefully observe the configurations, I'll write it and show here. Let us write all the configurations. So first configuration is noble gas core 3s2 3p1. Next I'll write all neon only first. Neon 3s2 3p. This is 3p2. This is 3p1. And last option is 3s2 3p3. And option B is 3D10 4s2 4p3. Okay. So amongst all these options, this is option A, this is option B, this is option C, this is option D. Yes. If you see amongst options, option A if you observe, option C if you observe, and if you option D if you observe, yes, A, C and D, yes, they have highest ionization energy. They have highest ionization energy because extra stability is associated with half filled 3p orbitals. So amongst these, D, amongst these, all not all of them. So amongst A, C and D, D will have highest ionization energy. So D will have highest ionization energy amongst the three. Yes, why I'm saying amongst the three? Because all of them have 3s and 3p electrons. Therefore, in case of D, how it is? It is half filled. Spin up, spin up, spin up. It is half filled. That accounts for extra stability. That accounts for extra stability. So losing the electron from half filled configuration becomes difficult. So ionization energy will be more among A, C and D. Okay. If you compare it with B, option B, as the result in 4p electrons. See, here also you will say that 4p is having 3 electrons. When you compare this D option of 3p electrons with the B option of 4p electrons, the 4p electrons are far from the nucleus. They are far from the nucleus. Thus, they do not experience what? They do not experience much attraction from what? They do not experience much attraction from, or you can say towards the nucleus. Towards the nucleus. Much attraction towards the nucleus as compared to 3p. Of course, there is extra stability, but when you compare these two, this becomes more stable because the distance between the nucleus and the third shell is very less compared to distance between the nucleus and the fourth shell. Yes. Therefore, what is the correct option? The correct option is option D. That will have highest ionization energy. It will have highest ionization energy. Is that right? So option D will have highest ionization energy. Identify the correct order of size of the following: Ca plus 2, K plus 2, Ar, Cl minus, S minus 2. Let us first verify, are they isoelectronic ions? Okay. So Ca plus 2, in all the options these are there. K plus Ar, sorry, nothing is there because argon, noble gas. Cl minus, S minus 2. Calcium 20, potassium 19, argon 18, chlorine 17, and sulfur is 16. So there are 20 electrons. Calcium plus 2 means what? There will be 18 electrons. So less 2 electrons less. So K plus 19 electrons plus 1 means what? Less than 1 electron less. So it is also having 18. Argon is also having 18 electrons. Chlorine 17 minus they have said. Therefore 17 minus 1 means what? 17 plus 1, that is also equal to 18 electrons. Sulfur is 16 minus 2 means addition of 2 electrons. It will have is also having 18 electrons. So yes, all of them are isoelectronic. We have discussed that among isoelectronic ions, ionic radii, ionic radii of anions is more than cations. Ionic radii of anions is more than that of cations, right? Further, if you consider anions, the size of anion, this is first point. Second point, if you consider anions, size of an ion increases with increase in negative charge on the anion. Okay, and size of cation decreases with increase in positive charge. Understanding these 3 points are very important. Ionic radii of anions, in case of isoelectronic ions where there are same number of electrons, ionic radii of anions is more than cations. Ionic radii is more. Size of anion increases with increase in negative charge. So these are the two anions. Size of anion increases with increase in negative charge. So S minus 2 has greater charge. They have been descending order. So we will come in opposite way. Size of cation decreases with increase in positive charge. So which is least? Ca plus 2 is least. Then comes K plus. Then comes neutral atom Ag. Then comes, sorry, Ar. I'm very sorry. Then comes what? Then comes Cl minus, and then comes S minus 2 according to these 3 points. So cations have smaller size and anions have larger size. In case of cations, as the charge increases, the size decreases. In case of anions, as the charge increases, the size also increases. Yes. So which is the correct option? The correct option is Ca plus 2 smallest, okay, K plus smallest, Ar, Cl minus, and then S minus 2. Correct. Next question. With which of the following electronic configuration an atom has the lowest ionization enthalpy? So where ionization enthalpy is lowest, that means where electron can be removed very easily. Yes, we know that factors affecting ionization enthalpy, larger as it is, one of the factor is size of the atom. As the size of the atom increases, ionization energy decreases. As size of the atom increases, ionization energy decreases. So if you carefully observe here in option A, 1s2, 2s2, there are two shells. Yes. In option B, there are three shells. First shell, second shell, and this is the third shell. In all the three options, A, C, and D, there are only two shells. As the principal quantum number increases, or as the shell number increases, this shell number, N stands for shell number 1, 2, and 3. As the shell number increases, the orbitals present in that shell will have larger size. Yes. So when they have larger size, so here I can show you all here. As the shell number increases, as N increases, the orbitals will have larger size. The orbitals will have larger size, correct? So as shell N increases, the orbitals will have larger size. So you can see here, In case of option B, there are three shells. There are three shells. That means and the outermost electron has to be removed from the outermost shell only. So larger the atomic size, smaller is the ionization energy. That means I need very less amount of energy to remove the electron from the larger atom. Yes. Again, next concept is higher the screening effect. Higher the screening effect, as screening effect increases, that means as the inner electrons shield the outer electron from nuclear attraction, ionization energy, what happens? Lesser is the ionization energy. So when the inner electrons, when they shield the valence electron, when it screens the valence electron from the nuclear attraction, the nuclear attraction on this valence electron decreases. So when this decreases, what happens? Ionization, very less amount of energy is required to remove the electron. So these are the two factors, do remember. Larger the atomic size, smaller is the ionization energy, lower is the ionization energy. Again, high the screening effect, lesser is the ionization energy. So which will have lowest ionization energy? Option B, with 1s2, 2s2, 2p6, 3s1. So you can see here there are 10 inner electrons, they will screen. First thing is atomic size is large, because third shell. Second thing, inner 10 electrons will shield the outermost or valence electron from nuclear attraction, thereby reducing the nuclear charge on it. Therefore, very less amount of energy, even if I put, the electron will be lost very easily. So this will have the least ionization energy. It will have the least ionization energy. Okay, next question. Which one of the following ionic species has greatest proton affinity to form stable compound? That means which one will take NH2 minus, F minus, I minus, HS minus. These are the negative ions. Which one will take the proton? Which one will take the proton to form, that means proton affinity. Which one will accept proton very easily to form a stable compound? Please do remember accepting the proton. Yes, that also has variation. When you move across the period, that is from left to right in the periodic table, the basicity means what? Proton affinity. Basicity is nothing but proton affinity. So across the period, the basicity decreases. Basicity decreases. Why it decreases? Because electronegativity of atom possessing lone pair of electrons increases. Electronegativity, just remember, electronegativity of the atom increases. Therefore, basicity, that is proton affinity, decreases. Yes, proton affinity decreases. Hence, I can say basicity of NH2 minus is higher than F minus. Yes, because across the period it decreases. Then further, so NH2 and H minus is done. On moving down the group, what happens? As atomic size increases, what happens to the basicity? Basicity decreases. Hence, I can say F minus is more basic than I minus and HO minus. F minus is more basic than I minus. And further, HO minus is more basic than, this is not given in our option, but still, HO minus is more basic than HS minus, because oxygen, below oxygen is fluorine. So HO minus becomes more basic, because as you move down the group, the basicity decreases. Hence, given among the given following species, which one has highest basicity? So I can say NH2 minus is has highest basicity. Understood? That means it is having highest proton affinity. So it will accept affinity. It will accept the proton immediately to form the stable compound, that is NH3, form the stable compound. Okay, so across the period, basicity, that is proton affinity, decreases because electronegativity of the atom possessing lone pairs, having unshared electron pairs, it increases. Therefore, we say basicity of NH2 minus, nitrogen is having unpaired, unshared electrons, and here fluorine is having unshared electrons. So it is higher than fluorine. When you move down the group, as atomic size increases, basicity decreases. Therefore, fluorine is more basic than I minus, and HO minus is more basic than HS minus. Therefore, when you compare all of them, first comes NH2 minus, then comes F minus, then comes NH2 minus, then comes F minus, then comes HO minus, then comes HS minus. Therefore, among all of them, this is most basic. That becomes most basic. So, NH2 minus is the correct option. That has maximum proton affinity to form the stable compound. Next question. Which of the following is most basic oxide? Okay, so options: selenium oxide, aluminium oxide, strontium oxide, and bismuth oxide. Selenium oxide is acidic oxide because it is a non-metallic oxide. Aluminium oxide is amphoteric oxide. Even strontium oxide is amphoteric oxide. Amphoteric oxide. Bismuth oxide is basic oxide because for any elements of group, when you move down the group, metallic nature increases. Yes, bismuth comes at the bottom of a group. Therefore, bismuth is a metal and it forms a basic oxide. So, what is the question? Most basic oxide. So, it is bismuth oxide. That is most basic. Okay. Next question. In which of the following arrangements the sequence of given the given sequence is not strictly according to the property indicated against it? Yes, HF, we have solved the such question once. So HF, HCl, HBr, HI, increasing acidic strength. Yes, see, as acidic strength increases, pKa value, dissociation constant for an acid, pKa value decreases because Ka value increases. Yes, so as acidic strength is increasing like this, HF, HCl, HBr, HI, this format what they have shown, this is increasing acidic strength only. This is increasing acidic strength only. That means in this order, pK value should decrease. But here they have said increasing pK value. So that is the option which is not strictly according to the property indicated against it. Ionic radii are inversely proportional to effective nuclear charge, inversely proportional to square of effective nuclear charge, directly proportional to effective nuclear charge, directly proportional to square of effective nuclear charge. Ionic radii, effective nuclear charge. See, as nuclear charge increases, ionic radius decreases. So it is inversely proportional to effective nuclear charge. There is no square or anything as such. So as ionic radii increases, if nuclear charge increases, ionic radii decreases. As effective nuclear charge decreases, ionic radii increases. That it is inversely proportional to effective nuclear charge. Next question. The ions O2 minus F minus Na plus Mg plus 2 Al plus 3 are isoelectronic. They are ionic radii. We know this. So if you want to write, you can write which comes first. Al plus 3 is having least ionic radii. Then comes Mg plus 2. then comes Na plus, then comes F minus. Highest ionic radius is for this. Okay, they are ionic radii. A significant increase from O2 minus to Al plus 3. Is it significant increase or significant decrease? It is significant decrease. Can you see this? So there is significant decrease from O2 minus to Al plus 3. So this is correct. Let us see. An increase from O2 minus to F minus and then decrease. No, such thing doesn't happen. Decrease from O2 minus to F minus and then increase. No, that also doesn't occur. So there is significant decrease from O2 minus to Al plus 3. So amongst isoelectronic ions, we know ionic radii of anions is more than that of cations. Further, size of anion increases with increase in negative charge and size of cation increases with decrease in the positive charge. Correct? Okay. Next, which of the following order is wrong? NH3 pH is less than pH3 is less acidic than ASH3. Lithium first ionization energy of lithium is less than beryllium is less than boron is less than carbon. The basic nature of aluminum oxide is less than magnesium oxide is less than sodium oxide is less than potassium oxide. Ionic radius of lithium is less than sodium ion is less than potassium ion is less than cesium ion. Okay, which one is order is wrong? See, this is nitrogen, phosphorus, arsenic. As you are moving down the group, what happens? What happens as you move down the group? Basic nature of the oxides increases, correct? But here acidic nature is decreasing, yes or no? So I can say here, in case of option 1, NH3 PH3 ASH3, what is happening? Acidic nature is decreasing, they have said. Yes, we know that when you move down the group, basic nature of hydrides, acidic nature of hydrates decreases. So this is most acidic. So NH3 is less than, okay, acidic nature of hydrates increases. So this is less than pH3, this is less than ASH3. That is correct. Second option, lithium, beryllium, boron, carbon, first ionization energy. Across the period, ionization energy increases. So lithium is having least ionization energy. Yes, generally we know that these are the elements which belong to same period. Okay, so generally the value of first ionization energy, it increases from left to right. It increases from left to right in a period. Why? Because nuclear charge of the elements also increases in the same direction. But if you look in beryllium and boron, this is 3, this is 4, this is 5. 1s2, 2s2, 1s2, 2s2, 2p1. Yes. So the ionization energy, the first ionization energy of boron is lower than the first ionization energy of beryllium, because in case of boron, the 2p electron has to be removed to get B plus. While in case of beryllium, the 2s electron has to be removed to get Be plus. Understanding? And we know that S is more penetrating towards the nucleus than P. So to remove S electron, we need to put more energy than to remove P electron. Are you all getting? To remove S electron, we need to put more energy. Therefore, ionization energy of beryllium is more than ionization energy of boron. So what is the correct value? Lithium, and ionization energy is less for boron, then comes beryllium, then comes carbon. So this is the correct option. Next, third option is aluminum oxide, magnesium oxide, sodium oxide, potassium oxide. Yes, as you move down the group, the basic nature increases. So they have given correct order. Okay. Lithium plus ion, Na plus, K plus, cesium plus. So as we move down the group, the ionic radius increases. It is least for lithium plus ion, then comes Na plus, then comes K plus, and then comes Cs plus. So rest all options are correct. Which is the wrong option? The wrong option is option B. about the first ionization energy. Correct order of first ionization potential among the following. Just now we have discussed. So which is first? It is boron, which is having least energy. Then comes least ionization energy. Then comes beryllium, carbon. Then comes oxygen. Then comes nitrogen. In this case, in this case, p electron has to be removed. Here, s electron. Therefore, here we speak about penetrating effect. Penetrating effect. That is the factor here, which makes boron to have less ionization energy than beryllium. But in this case, if you see, in case of oxygen, there are 2p4. Spin up, spin up, spin up, spin down. In case of nitrogen, it is 2p3. Spin up, spin up, spin up. So here, what accounts for extra stability? The half-filled configuration. The half-filled configuration accounts for extra stability. Accounts for extra stability. So this makes it more stable. Yes, therefore we say ionization potential, it increases across the period as atomic size decreases, but in case of atoms with fully or partially filled orbitals, they have high ionization potential. And here s electrons are more strongly bound to the nucleus than p electrons. Therefore more energy is required to remove s electrons than p electrons. Which of the following elements has maximum electron affinity? Yes, okay. Amongst halogens, these all are halogens. What are halogens? Group 17 elements. So amongst halogens, electron affinity means what? It is nothing but electron gain enthalpy. Yes. So electron gain enthalpy expected as we move down the group, expected is fluorine should have highest, then chlorine, then bromine, and then iodine. Yes. So fluorine should be maximum. But if you see, as you move down the group, the atomic size increases. We have discussed this. In case of fluorine, since electron will be added very easily because nuclear attraction is strong, because atomic size is small. But because of small atomic size, the electron-electron repulsions are also strong in case of fluorine, which makes this incoming electron difficult to enter. Therefore, less amount of energy will be released. Whereas in case of chlorine, since the atomic size is large, there will be not much electron-electron repulsion. Therefore, the incoming electron will be taken up or gained very easily, releasing large amount of energy, making it exothermic. So we say due to small size, there is inter-electronic repulsion in fluorine. There is difficulty to the entry of new electron. I'm not saying we have to put energy. No, energy will be released. But comparatively in chlorine, there is less inter-electronic repulsion. Then for electron affinity or electron gain enthalpy value is slightly lower than chlorine. So which is the correct order if you want to say? Lowest is for iodine, then bromine, then fluorine, and then chlorine. So where it is maximum? It is maximum for chlorine. It is maximum for chlorine. Did you get it? Okay, next. The first ionization potentials of beryllium and boron respectively are. Okay, so you have to just, you need not calculate here, you need to just say which is more or which is less. Okay, beryllium 1s2, 2s2, boron 1s2, 2s2, 2p1. So in case of beryllium, one reason is I'm speaking about 2s and here I'm speaking about 2p. Okay, fine. So 2s, 2 electrons, 2p, 1 electron. Due to stable fully filled s orbital in beryllium, one reason is due to stable fully filled, completely filled s orbital arrangement of electrons in beryllium atom, more energy is required to remove the electron. Yes, than boron. So in this case, I can say beryllium has higher ionization energy. The ionization energy of beryllium is more than ionization energy of boron. Second way how to give explanation is, in beryllium, electron is removed, has to be removed from which orbital? S orbital. S orbital. Okay. In case of boron, electron has to be removed from p orbital. And we know that S orbital has more penetrating effect, one of the factor of ionization potential, penetrating effect than p electron. That means you need more energy to remove s electron. So ionization energy required to remove s electron is more than ionization energy required to remove p electron. Therefore, what we say? We say to remove beryllium we need more energy than to remove boron. So which is the correct option? The correct option. This cannot be the option. 8.29, 8.29. 9.32, 9.32. No. 8.29 of beryllium. 9.32 of boron. No. 9.32 of beryllium. It is more. And 8.29 of beryllium. Yes. So this is the correct option. A 9.32 for beryllium. 8.29 for boron. Correct? Yes. So option D is the correct option. Option D is the correct option, right? Next question. Which one of the following is correct order of a size of iodine species? Now we know cations are always smaller than the respective ions, respective metals. Cations are always smaller than respective metal atoms. Respective atoms, I will say. And anions are always larger than the respective atoms. So which is smallest? They have given in increasing order. So which is largest? I minus is largest. Then comes I and then comes I plus. So this is smallest atomic size, ionic size. This is largest ionic size. So in case of ions, this is has to be followed. Which of the following ions is largest in size? K plus, Ca plus 2, Cl minus and S minus 2. All are what? All of these contain, this is 19, 20, 17, 16. So 19 minus 1 is 18 electrons, 20 minus 2 is 18 electrons, 17 plus 1 is 18 electrons, and 16 plus 2 is 18 electrons. So all of them are isoelectronic. They contain 18 electrons. And for isoelectrons, we know that anions are larger than cations. Second thing, we know that anions with larger negative value is largest. So S2 minus has largest. Then comes Cl minus. Then comes, in case of cations, as the charge on cation increases, the size decreases. So K plus and then comes Ca plus 2. So this is the correct order. So which is the largest in size? It is Cl minus has the largest size. Which of the following have smallest size? Aluminium atomic number 13, sodium 11, fluorine 9, magnesium 12. 13 plus 3 minus 3 is 10 electrons. 9 minus 1 is plus 1, 10 electrons. Na 11 plus 1 is minus 1, 10 electrons. 12 plus 2 is minus 2, 10 electrons. So all are isoelectronic ions. Just now we have discussed. Anions have largest. Cations with larger charge have got smallest value. So which comes first? Al plus 3 has smallest size. Then comes Mg plus 2. It is smaller than Na plus. It is smaller than F minus. So which is having large smallest size? It is Al plus 3. It is having smallest size. Is that clear? You can see here. I have told. Yes, and I have mentioned also. Anions are larger than cations. First point. Second point, larger the charge on anion, larger is size. Third point, larger the size, charge on cation, smaller is the size. Smaller is the size. So correct, smallest one is Al plus 3, largest one is F minus. Largest one is F minus. Correct? Next, among the following oxides, the one which is most basic: zinc oxide, magnesium oxide, Al2O3, aluminum oxide, Al2O5, nitrogen pentoxide. Zinc oxide and aluminum oxide are what? They are amphoteric in nature. They react with both acids and bases. Magnesium oxide is an oxide of metal. It is basic in nature. Nitrogen, and it is a active metal, so it is strongly basic, I can say. Strongly basic. Oxide of nitrogen, a non-metal, it is acidic. So question is, among the following oxides, the one with most basic nature, it is magnesium oxide. Which one of the following has largest size? Which one of the following has largest size? So in case we know that anion, largest, then neutral atom, please do remember this, then cation. Correct. So here, which is having largest size? Na minus, then comes Na, then comes Na plus. So the cations are always smaller than neutral atoms and anions are always larger than neutral atoms. So largest size is for Na minus. It is for Na minus. Correct. Na plus, Mg plus 2, Al plus 3, Si plus 4 are isoelectronic order of their ionic sizes. So all are cations. Larger the size of cation, smaller is the, as the size of cation decreases. When the size of cation decreases, when magnitude of charge increases. Yes. So which is smallest? Which is largest? Na plus is having greatest atomic ionic size. Then comes Mg plus 2. Then comes Al plus 3 and then comes Si plus 4. So which is correct option? It is option C. This is the correct option. In the periodic table from left to right in the period, atomic volume. What happens to the atomic volume? Within the period, when you move from left to right, atomic volume first decreases. First decreases and then increases. Yes, please do remember it for atomic volume. So from left to right in the periodic table, from left to right, atomic volume first decreases and then increases. First decreases and then increases. Which electronic configuration of an element has abnormally high difference between second and third ionization energies? Very good question. 1s2, 2s2, 2p6, 3s1. 1s2, 2s2, 2p6, 3s1, 3p1. 1s2, 2s2, 2p6, 3s2, 3p2. 1s2, 2s2, 2p6, 3s2. Okay, let us see. So the question asked is, which electronic configuration has abnormally high difference between second and third? First option, 1s2, 2s2, 2p6, 3s1. Okay. So let me call all of them as metals, element M. Okay. So this element has got, I'll write the configuration 281 like this. So first ionization enthalpy is applied. It becomes M plus, one electron comes. So 2, 8. Okay. Then if I try to put for again ionization energy second, it becomes abnormally high to form M plus 2, because once it has lost one electron, what happens? It has attained stable configuration. So for first explanation, I can say the second ionization energy is, there is abnormally high difference. Abnormally high difference between first ionization energy and second ionization energy. Correct? First and second. Because I write it here, the second ionization energy is very, very, very high than first ionization energy, because I cannot remove the second electron after that. It retains stable configuration. Understood? Second option, 1s2, 2s2, 2p6, 3s1, 3p1. Okay. Suppose here 2, 8, 2. Okay. Now 3s1, 3p1. So I am going to remove the first electron, first ionization energy. So this electron will be removed. Actually, it should be 3s2. The question is wrongly printed. It should be 3s2 because once this is filled, then only this will be filled. So it is 3 here. Okay. So what happens? It forms M plus. M plus second ionization energy plus M plus 2. M plus 2. So here what will be the configuration? 282. Here it will be 281. M plus 2. 281. Third ionization energy. 28 will be there. M plus, it will form M plus 3. M plus 3, 2, 8. Apply fourth ionization energy. It will be difficult. So in second option, the fourth ionization energy is abnormally high than the third ionization energy, which is high than second ionization energy, which is high than first ionization energy in second example. Okay. Coming to the option C, 1s2, 2s2, 2p6, 3s2, 3p2. So here if you see 4 electrons have to be removed, then it becomes abnormally high. Option D, that is also we know. Option D, 1s2, 2s2, 2p6, 3s2. Okay, so this has 2, 8, 2 configuration. I will apply first ionization energy. It will form M plus 281 configuration. M plus with 281 configuration. I will apply second ionization energy. It will form M plus 2 with 28 configuration. Now this M plus 2, if I want to remove one more electron, that means that I'm going to apply third ionization energy. It will be not that easily possible. So abnormally, what I say, the third ionization energy is abnormally very high than the second ionization energy, which is high than first ionization energy, because after losing the two electrons, that a particular atom becomes very stable. So abnormal difference comes where? In second and third ionization energies here, in case of option D. In case of option D. So which is the correct option? It is option D. Abnormally high difference between second and third ionization energies. One of the characteristic properties of non-metals is they are reducing agents. No, metals are reducing agents. They form basic oxides. Metallic oxides are basic. Non-metals are oxidizing agents. Non-metals form acidic oxides. They form cations by electron gain. No, by electron gain they form anions. Next, they are electronegative. Yes, non-metals characteristic property is that they are electronegative. Which one of the following has minimum value of cation to anion ratio? Just now I have told you, if the larger the cation size and smaller the anion size, ratio of cation radii to anion radii will be maximum. Yes, they have asked minimum. Yes, so you just see it is sodium chloride, potassium chloride, Mg chloride, magnesium chloride, calcium fluoride. The order of ionic size for the given ions will be what? Sodium, potassium, magnesium, calcium. So which will have largest size? K plus. Then comes Ca plus 2. Then comes Mg plus 2. And then comes Na plus. Correct? And that of chlorine and fluorine, if you see, Cl minus, then comes F minus. As we move down the group, atomic size increases. Correct? Therefore, so where the ratio will be maximum, when larger the size of cation, smaller the size of anion. Where the ratio will be minimum, smaller the size of cation, larger the size of anion. So Mg plus 2, Na plus comes here. Mg plus 2 divided Mg plus 2, and in case of anion, larger the size of anion, Cl minus. So it is MgCl2. this will have the minimum value of ratio of cation to anion ratio. Cation to anion ratio. Correct? Understood. So if you want maximum, larger the size of cation and smaller the size of anion. If you want minimum, smaller the size of cation, larger the size of anion. Next. Which of the following sets has strongest tendency to form anions? Which one will form anions? Non-metals form anions. Non-metals have the strongest tendency to gain electrons and form anions. So if you see out of these options, nitrogen, oxygen and fluorine, they are highly electronegative non-metals. So they are what? They are highly electronegative non-metals. And they will have the strongest tendency to form anions by gaining electrons from where? By gaining electrons from metal atoms. So from metals they gain electrons. So this is having the strongest tendency to form anions. Next, elements of which of the following groups will form anions more readily? Where anions are formed more readily? That depends upon the electronegativity. As the electronegativity increases, and even it depends upon electron gain enthalpy. So where electron gain enthalpy is highest, delta H, e.g. negative is, this is more negative for which family? Across the period it becomes more negative, we say. So last is what? Don't compare noble gases because they are very stable. So last comes what? It comes group 17. So halogens, they will form anions more readily because as halogens have the outermost configuration. Nitrogen, if you see, this belongs to alkali metals, they are positive. Yes, they tend to lose electrons, right? Nitrogen family, boron, carbon, nitrogen 15 group family, oxygen 16 group family. So here it is ns2 np 3, here it is ns2 np4, here it is ns2 np5. So immediately they have, or they need only one electron to form the stable noble gas configuration. Yes, so this is the valence shell. They have strong tendency to acquire nearest noble gas configuration by gaining an electron from metallic atom and form halide ions. This is very easily. Therefore, they will form anions most readily. They will form the anions most readily. In the periodic table, with the increase in atomic number, the metallic character of the element, what happens? See, across the period, what happens to the metallic character? It decreases. Down the group, it increases. Yes? So, across the period, metallic character decreases. And down the group, metallic character increases. It increases. Yes. Therefore, which is the correct option? Decreases in a period and increases in a group. Yes. Which of the following atoms will have smallest size? Beryllium, magnesium. So lithium is here, sodium is here, beryllium is here, magnesium is here. Across the period, atomic size decreases. Yes. Down the group, atomic size increases. Correct. Therefore, for lithium and beryllium, lithium is having more atomic size than beryllium. For sodium and magnesium, sodium is having more atomic size than magnesium. Correct? Okay. So the size increases when you go from in a group from top to bottom. So lithium and sodium is having more atomic size than lithium, and this comes later. Therefore, which is having smallest size? Overall order, if you want to write, Overall order will be sodium, magnesium, lithium, and then beryllium. Correct? So which will have smallest size? The smallest size is for beryllium. Beryllium will have the smallest size. Beryllium will have the smallest size. Next question. Which of the following statements is correct with respect to the property of the elements with increase in atomic number in the carbon family? Carbon family, group 14. Okay. So as we move down the group, what happens? Which is correct there. Atomic size decreases. No, atomic size increases. So that is wrong. Ionization energy increases. No, ionization energy decreases as we move down the group. Metallic character decreases. No, metallic character increases. Stability of +2 oxidation state increases. Yes, that is correct. That is, see, from group 14, 15, 16, 17, if you see, we expect 14. 14 carbon family has got 4 electrons, so +4 we expect. 15 plus 5, this expect +6 +7, like this. But when you go down the group at the bottom elements, what happens, since ns orbital is very nearer to the nucleus, these electrons, they do not take part in bonding. Therefore, in all the cases, ns electrons become less for bonding. Ns has how many electrons? 2 electrons. So in all the cases, there is a fall in the oxidation state by 2. Therefore, this becomes +2. Here it becomes +3. Here it becomes +4. If I am speaking about positive oxidation state. So stability of +2 oxidation state increases. So that is the correct statement. Next. Yes, so therefore, as we go down the group, inertness of Ns2 electrons increases. Hence, tendency to exhibit +2 oxidation stable state increases than that of +4. That is called inert pair effect. It is called inert pair effect. Okay. The pair of amphoteric hydroxides. Yes. If you see aluminum hydroxide, lithium hydroxide, no. Aluminum hydroxide is amphoteric, but not lithium hydroxide. So, which is the correct pair? Beryllium hydroxide and magnesium hydroxides are pair of amphoteric oxides because they are similar. Based on which principle? Diagonal relationship. Based on diagonal relationship, beryllium oxide and magnesium oxide are same. Therefore, they are amphoteric in nature. They are amphoteric in nature. Okay, which has the highest melting point? Which has the highest melting point? Okay, lithium chloride, beryllium chloride, boron chloride, and carbon tetrachloride. We have discussed this question. Beryllium chloride has highest melting point because in beryllium chloride, let's all have covalent bonding, but beryllium chloride there is ionic bond, and ionic bond is stronger than covalent bonding. Yes, and here there is also ionic nature, but it is less than beryllium chloride. So that has highest melting point. Arrange sulfur, oxygen, and selenium in the order of increasing electron gain enthalpy. Okay. So, correct order. What is the correct order? See, oxygen, sulfur, selenium. They are like this. Fine. So, which is having the highest electron? As you move down the group, electron gain enthalpy becomes less and less negative. So, correct order is, it is oxygen, then comes selenium, and then comes sulfur because of the atomic size. So electron gain enthalpy is this the correct order. Which of the following is not correct is not the correct increasing order of ionization enthalpies? So which is not correct? Ionization enthalpy. Cl minus, Ar plus, K plus, isoelectronic. Correct. Au, Ag, Cu. What is the correct increasing order? Across the period, ionization energy increases. So correct is Cu, then Ag, and then Au. Yes. Next, Cs, cesium, rubidium, potassium. Correct. Potassium, calcium, scandium. That is also correct. So option B is not the correct increasing order. Next question. Increasing order of electronegativity is bismuth is there, phosphorus, sulfur, and chlorine. Increasing order. So where increasing order? So for these options, see, as we move down the group, electronegativity decreases. Across the period, electronegativity increases. So which comes first? Bismuth is less than phosphorus, which is less than sulfur, which is less than chlorine. These are group period 4 elements. They are period 4 elements. So correct option is option A. It is option A. What will be the order of first ionization energy? So what will be the correct order? Lithium. As you move down the group, the ionization energy decreases. So lithium is highest, then comes sodium, then comes potassium. This is only the correct. Rest all are not the right options. Which of the following electronic configuration represents atoms of elements having highest second ionization energy? So because for removing the second electron, it has to be taken out from the stable configuration where you need stable. So here 2s2 2p4. So there is no such stability. Here in fact instead of removing the electron I need to add. So first electron only cannot be removed very easily. Here also not the case. Here if I remove first electron, it will attain stable configuration of 8 electrons. Therefore here itself, to remove the second electron, I need to put very high ionize. So second ionization energy, that is very, very high than first. In this case, after removing 2 electrons. So here I can say third ionization energy is very, very high than second, which is high than first ionization energy. The first ionization potentials in electron volts of nitrogen and oxygen. Which will be more? Nitrogen will be more because of the stability of half-filled configuration than oxygen. So nitrogen should be more, oxygen should be less. So which is the correct option? Correct option is what? First ionization energy of nitrogen is more and oxygen is less. So it is option A. The elements which occupy peaks of ionization energy curve are. So peaks of ionization energy curve, noble gases occupy. So all the noble gases, they occupy the peaks of highest peak, highest. It is highest. Ionization energy is highest means what? They have occupied the peaks. So all the noble gases, they occupy the peaks of ionization energy curve. So it is option D. Which is the correct order of ionic sizes? Atomic number of cerium is 58, Sm10 is 50, ytterbium is 70, and ruthenium is 71. So these are some of the elements from actinides, right? So correct order, they have given the atomic numbers. So you can see here, cerium is 58, 50 is here, tin. Then they have given the elements. So which is the correct order? Ytterbium is there and ruthenium is there. So the correct order comes to, if you observe, atomic number 50, tin comes, is more ionic size, then comes cerium 58, then comes ruthenium 71, and then comes ytterbium, it is 70. So this is the correct order. So with this, we have discussed almost all the questions, all the concepts, questions based on all the concepts. Hope you have followed. And here I have made a small difference between electron gain enthalpy and electronegativity. Change in enthalpy when neutral atom or molecule gains electron. It is the ability to attract shared pair. Measured in kilojoules per mole, it is unitless. It is measured by Pauling scale. Here, one more point you can say, it can be negative, it can be zero, it can be positive. Here it is always positive values. Measures the amount of energy, measures the ability to attract electrons. Can be either positive or negative depending upon the electronic configuration that is going to gain an electron, always a positive value. So this completes this third topic. In the next video, we'll start with the next topic. For now, please practice all remaining questions. If you have any questions, please do practice them. Make the concepts very clear. Thank you.